Hey everyone, this is Dan, and today we're going to talk about particlesGpu and more specifically effectors, which are kind of an advanced feature of particlesGpu. It's a very powerful feature which not a lot of tutorials talk about, and I'm going to today try to demystify it, and as a result give you more control over particlesGpu, which is a very, very cool component in TouchDesigner in my opinion. This can be considered a part 2 of my previous particlesGPU tutorial. I'm going to cover some of what we've covered there and much, much more. So let's see what we're going to end up with today. So first, we're going to look at the basics of using effectors. For example, I can set up zones where turbulence has an effect, in this case, only on the right side, or only inside a sphere with a little fall off also, as well as the color, by the way, is controlled by an effector, or in this case, in a band or in a lane. So this can give you a lot more control over what happens with particlesGPU. It's also super useful for kind of 2D effects. As you can see here, in this case, only the brighter parts of the image are affected by turbulence. As you can see also here maybe. And this also looks kind of cool with like webcam. So the brighter parts of the image have more going on, as you can also see here. So yeah, we're going to take a look at all this. The project file is going to be available on my Patreon, as well as a ready-made particlesGPU Ultimate component, which you can see here. And this has effectors already set up for you in a very easy to use way for live turbulence and wind. Also a sequence for forces, for extra forces, as you can see here. So I can just add more forces like this, which can be very, very neat. So all this and much, much more on my Patreon. I also wanted to showcase some real-life applications of particlesGPU and effectors. So this is an installation that we did with our studio, the Real Studio, at Encounters Berlin. Here we're dealing with a corridor situation and CRT TVs. Long story short, each TV is a little window onto the 3D scene that we are rendering, as you can see here. As people depicted here by these blobs walk close to either side of the corridor, the particles are either going away from them or coming towards them. And this is using particlesGPU wind forces using effectors based on their position. So this is the first one I wanted to show. The next piece I wanted to show is again using effectors and particlesGPU. And again, this is something we did together with our studio, the Real Studio, at Kunstkraftwerk Leipzig. And it's part of a Monet immersive experience show. The idea is that the brighter pixels generate bigger particles and also more movement. This is just, by the way, just a test footage I was able to find, but I hope you get the idea from this footage. This piece we did together with Drasko V and Torian Blankensmith in Santa Monica, Los Angeles. And this is also using particlesGPU and effectors, as you might have guessed. This is based on images generated by Drasko, and the principle is kind of the same as the Monet one, where brighter pixels generate more movement and so on. So we're gonna learn how to do this kind of stuff today. So we've all seen this starting version of particlesGPU. I'm gonna change a few things here. I'm gonna change the material to line, so we get these nice particles here. And that's basically what I'm gonna do. Let's see, what are effectors and where can we find them? For example, in the case of turbulence, there's a type constant, and we will find the effector here. Same with wind, external type also, the size as an effector. So most options in particlesGPU will have an effector lookup available. So the problem with the turbulence right now is if I want to add turbulence to this particle system, I can only affect either all the particles, or I can affect them based on their age or their velocity. But if I wanted to select a specific region to affect, I wouldn't be able to do that unless I'm using effectors. So let's see how we can do that. First of all, since we're gonna affect these particles based on their position, we need position information. And fortunately, the second output of particlesGPU gives us the position in a top, the positions in a top. So if we have a look at it, we indeed have these positions encoded in this top. For those who are not familiar with top instancing and this kind of workflow, each pixel here represents a particle with RGB representing the X, Y, Z coordinate of that particle. And what we need to do is kind of tell particlesGPU which of these particles or pixels should be activated for the turbulence. So we will need to input that information into the effector input, which is the last input. But since we're kind of moving backwards in our network, if I just, for example, just connected this back here, particlesGPU would stop working because we are hitting a Cook dependency loop, kind of. So that will not work. And for that, we can always use a feedback. So let's put down a feedback. Let's drag and drop this onto there. But obviously we need an input for our feedback, which, for example, if I used this same position here and input that into the effector, we would still have a loop. So that's not going to work for us, even if I use the select or whatever. So we're going to need kind of an independent source just for this input feedback. So if we go inside, we have this beautiful texture, so we can select that. I'm just going to copy its name. This is going to give us a good reference for the texture size of our feedback. So I'm just going to put down a select here and select particles GPU / constant max particles, like so. Use that, and suddenly this is not working because we don't have a loop anymore. But our effector is not doing too much yet. I'm just going to do a little bit of cleanup here. Let's disconnect this for now. I'm going to put null after this and just say null position feedback. Let's do the following. Let's create a mask that only selects particles that have a positive X value. We can do that easily with a threshold. I'm just going to select this. I'm, by the way, using my toolkit's Alt select feature. So I just drag an operator, hold Alt, and then just drop it, and that creates a select. And I'm going to put down a threshold, select the RGB to red. So we are only thresholding based on the red channel, which is the X channel. Never mind all these pixels that turned white. We actually don't really care about those. We can double check what this is doing if we multiply our general position texture with this mask. Let's do that. Let's activate this hit V to go into this viewer, and we can see that we are indeed cutting off particles that have a negative value. So let's check if I'm moving this about, it cuts off also other particles. So this is working. This is giving us a good mask. I'm just gonna keep this on the side, bypass this. So we can put on a null and call this null eTurb. So this is gonna be our turbulence effector. Let's clean this up. And I'm gonna select this also back up here. It's always important to keep a clean network. And if I input this to the effectors, then we can see that not much is happening yet. And that's because we need to set up our turbulence lookup job. So this lives here. And if we jump to this operator, we get inside particlesGpu where the default one is living. And I just need to change one thing here. I'm going to change the last constant force turbulence magnitude to something else. And that will give us the effect that we're looking for. Only the right side is being affected by this turbulence. Now let's actually understand what's going on with this lookup. Let's copy and paste these outside. And we can close this now. We can reference this job here for our turbulence lookup. And let's get rid of these errors here. I'm actually going to get rid of this middle constant, let's say, because I just want to look up between two values or two turbulence settings. And currently these two constant jobs dictate what turbulence setting to apply to each particle based on their effector pixel value. So if a pixel is black, so we are not selecting it to the mask, it's going to apply these settings, and if it's white, it's going to apply these settings. So we can change these as we want. And that is officially our first effector done. But we can do much, much, much more with this. And let's take a look at the next example. But actually, before moving on, let's use this same effector for the color. So let's navigate to the color settings of the particlesGpu under render. Let's change this to effector R. And here we are operating with a lookup that's defined inside again. So let's navigate in there to null color. And let's see what's happening here. We have a pattern with an RGBA. So I'm just going to copy and paste that outside once again and reference that to my color lookup. Okay. Instead of a sign, maybe I'm just going to open this on the side for now in a small viewer. Let's change this type from a sign to a ramp. We can already see the separation happening. We have a phase step per channel. We don't need that actually. And currently the range is going from -1 to 1. I'm going to change that to 0 to 1, 0 to 1. And now we have a hard cutoff here. We could give it a little bit of a color for the non-selected particles too. And there we go. We have a separation going on in the colors also. For our next example, we're going to take a look at how we can select an area within a sphere and within a band. For that, we're going to use GLSL, but we're going to use AI code generation. We don't have to be afraid of GLSL too much. By the way, like Heckaman has a very great tutorial series on YouTube. You should check that out. But if you want to skip all that and get to the section where we talk about this kind of stuff, where we use an image's pixel values to affect our turbulence and whatnot, then you can skip there in the timeline somewhere. Otherwise, stick around for some AI GLSL action. Okay, so what we want to do now is, instead of just a simple left and right separation, we want to select values within a sphere. Let's see. So we will use GLSL for that. We could use just tops, but I find, especially now with all the AI code generation tools available, it's just much faster to do it with that. So we're going to put down a GLSL top. I'm going to open up Cursor, which is my choice of code editor. You can use ChatGPT or whatever to generate code for you. And let's write our prompt. I want to create a mask for incoming position pixel values inside of a sphere with radius 1. Let's see if this does something. Okay, let's see. From a first glance, it looks good to me. Let's go back to touch and see what it's doing. Again, I'm just gonna multiply this mask with the positions so we can see that it's indeed selected particles inside of a sphere. So that is awesome. Let's actually use this then, this lookup, effector, sorry, and it's kind of tiny now, so I'm just gonna increase the size. This is the distance that we can change here. Let's change it to 3. And here we can see that it's affecting particles inside of a sphere. Also, if I make it bigger, it's probably more visible. We can also just quickly increase the number of particles, at least double them, so you can see better. There's an extra step. We could specify that we want to have 2 radiuses, one where a fall-off is starting and where a fall-off is ending, because right now it's a hard cut of the effector. So it's now generating values either 0 or 1. And what if we want to have like a gradient fall-off of this effector? So let's tell our AI friend that I want now 2 radiuses, one where a fall-off begins and one where it ends. Let's hope this is enough. Radii, yes, that's the correct way to say that. Okay, it's now created 2 uniforms for us, which just means that it put these 2 radiuses in a parameter, so we can parameterize our little GLSL snippet here. So the 2 uniforms that we need to create are U inner radius and U outer radius. Let's copy and paste these into the vectors page of our GLSL top. U inner radius, U outer radius, and something is happening. Let's increase the outer radius. Yeah, I can see it happening, definitely. But there's not much contrast because our non-selected particles are also with a color. Now, if we change the lookup pattern here, so it goes from 0 to 1, we can definitely see the change happening, the gradual change. And I'm gonna give them still a little bit of a color. There we go. It's a little bit annoying though that our non-alive particles, because all these particles are actually not spawned, they also have a value of 1 here. So we can fix that in our code very briefly. We can multiply the mask value with the original position data alpha, and also use that position data alpha as our alpha. Like so. And then this is more clean, and here we can also see how our pixels have a gradient to them. They have a value between 0 and 1 somewhere. If I select 1, there we go, we can see it changing. So that's great. We're still not off the hook though, because our turbulence doesn't seem to have a fall off. It seems to be still a hard cut. So let's try and fix that. And the solution lies in our lookup, actually. If we have a look at our lookup, turbulence lookup, we can see that it's actually really a hard cut here in the middle. And that's because this stretch is set to no interpolation. If I set this to linear interpolation, it's a little bit hard to see maybe how this is doing a gradient change, but maybe if I switch between the two, you can kind of see it happening. Linear on, linear interpolation on, and then linear interpolation off. As an extra step, we could separate these 2 effectors for the color and the turbulence into 2. So I'm gonna copy and paste this and call this E color, effector color. I'm gonna select this with Alt drag using my toolkit. And then the thing is, we have only 1 input here. What we need to do is separate this into 2 different channels. I'm gonna reorder these I'm going to use input 1 as red, and we're going to use input 2 as green. And in our particles GPU settings where we set the color, we can set this effector to green, to the green channel. And now we can separate these two with, let's say, I can put down a function top, affect the RGB, and we can put up an exponent to it. So we can further customize this lookup curve, basically. And I can do a different one for the turbulence, where we can have, for example, no fall off whatsoever, or a very sharp fall off. That's what you would call it. In any case, we are just changing the curvature of this linear fall off to something with a curve like this or a curve like that. I'm not going to waste our time for the one band GLSL code. I'm just going to show it on the screen. You can pause and you can copy and paste it, or you can try and prompt it yourself. But as you can see, it's now selecting particles only within a certain band and the range. Let's now have a look at these examples where we take images or videos, pixel values, and affect certain parameters of particles GPU with those. All right, we're going to start with a clean particles GPU once again, and we're going to basically repeat my previous particles GPU tutorial in a way where we want a source image. Let's start with a noise. Let's add this as 1920 by 1080 or whatever you like. We will want to use this as a particle source color. But of course, we want to map this onto a flat grid. So let's create that grid particle source, which is the second input. And we're going to use a ramp for that. And one more ramp coming from this one. We're essentially creating a grid here. Let's make this vertical and also output set resolution only. Now we need to reorder these into an X and Y coordinate. So I'm going to use reorder. Essentially, we're creating a UV map. We don't need blue. We can put this as 0, and now we have a UV. That's great. So now if I plug this in here, we're going to have a teeny tiny particle source here. Let's remove the force that's acting on it right now. Also, let's change the material to line material, like so. But we want to match the aspect ratio of our source image. So I'm gonna put a null after this and call this null image. And the way we can match the aspect ratio here is with the point transform top. Here we can scale this to op null image dot aspect. Of course, if we have a look now here, it didn't scale because we were not in 32-bit float. So I'm going to set this first ramp as 32-bit float so we can go outside of the 0-1 range. And now the aspect ratio matches our image. As a next step, I would set up our camera to have the right aspect ratio, or like basically to fill the whole image with this particle system. So we can specify an external camera for particles GPU under the render tab. Let's do that. And we need specific settings here. Basically, we need to set, or we don't need to, but I like to set it as an orthographic in this case. And then we need to set the ortho width as the particles GPU resolution. So I'm gonna copy this parameter. I'm gonna paste it here. So we have paste the reference. We have a reference to this, and we need the division between the resolution width and the resolution height. So that gives us that. Now we can see that our particle system is not exactly aligned, and it's because this is centered around where the origin is around the center, while this is still bottom left centered. We can change that, for example, here. We can align this point transform with an align translate origin and also align translate y origin. So that puts it into the center, and now we're starting to look better. We can definitely change some settings of the particles GPU so we have a clearer picture. Let's decrease the particle size. Let's put it as constant actually. Let's decrease the size, and let's increase the birth like so. That is looking closer to what we want. Let's get rid of the turbulence, I would say, for now. And now we have a good starting point. Now we again need to create a position feedback, so we can select from inside particles GPU, select particles GPU slash, it was this one, constant max particles. We can use that. And we're going to do a feedback here of the second output, which is the position output. All right. And that's going to be our null position feedback. And we can use this as the basis of our lookup. So what do we want to achieve in the end? We want to have this image in the form of this texture, so 640 by 640. And we want to match each pixel, because the problem is, if you look at this, this is the position of our particles right now. Yeah, they are in a grid, nice and neat, but they are not in a regular UV order. Like our UV would be like this. So this is nice and regular in the sense that these points are sorted. So the bottom left pixel is the bottom left point here. The thing is with these particles GPU textures, and by the way, why is it noisy? It's because we are using here particle source interpolate source position. If I turn it off, it will regulate itself to a more regular grid. So the problem here is that these points are kind of random, unsorted. It means that the bottom left pixel of this texture doesn't correspond to the bottom left point in this grid. That's the problem here. But it's actually not a huge problem. It's just a different texture format. And by the way, this becomes more apparent when we actually correct our aspect ratio for these ramps, because normally they should follow our images aspect ratio. So we can multiply this by, or divide, let's see, op null image dot aspect. Yeah, we need to divide. Yeah, so this now corresponds to that. And normally, if, for example, if our position feedback looked like this, we wouldn't have to do anything. We could just use this image as our effector lookup, but it doesn't. Because in that case, there would be a one-to-one mapping of this bottom left pixel here, this bottom left position or particle, would get a lookup of this bottom left pixel here in our image. But that's not the case, as I said, so we need to do something there. We need to UV remap this image according to this position texture. So we do a remap, and then we need a reference to our image, and actually we want to remap this image with this position texture, and the resolution of this is not what we want. We want this. We can set the resolution source as UV image. Let's put down a null. And let's try and use this as our effector. So I'm gonna be proper. I'm gonna do a select here, connect it there, and move things a bit around. Just quickly, okay. And let's change the force turbulence to effector R. And we can see that it's kind of almost looking like it is working, but it doesn't match the position. And even I see that the aspect ratio is not matching. So let's correct that. Basically, we need to put a point transform here. And if I move this around, you see that those things move around also. So we need to make sure, because the remap works between 0 and 1, we need to remap the bounds of our grid, which we know from our aspect ratio. Basically, we need to do the inverse of what we did in this point transform. And let's do that. And actually for this, I like to use a math top more. It's a little bit more explicit in this case. And use the range tab. And we want to range from minus OP null image dot aspect divided by 2 to the positive counterpart of this. So that's gonna give us a good X. And then the range, we are between minus 0.5 and 0.5, and we rearrange that to 0 and 1. And we're definitely getting close to what we want to achieve. Let's change the pixel format of this noise to 30-bit float. And also, obviously, we need our lookup for our turbulence as before. So I'm just gonna, again, copy and paste this outside. I'm gonna remove the middle one. I just need to look up between 2 values. Let's get rid of these expressions. And then we also set the turbulence lookup as this one. We need to set, of course, the magnitude to something else here. The turbulence spread is way too high. Also, let's decrease the life, because now it's way too much. Let's do 3 and 1 maybe. And of course, let's not forget to set this stretch interpolation to linear. And that's gonna unlock what we want. We can kind of see that there's sort of a banding going on, and that's because we have only 22 samples of lookup here. If we can increase this to, for example, 100, there will be less separation between those. And then let's animate these translation parameters here. Let's do an apps time dot seconds times 0.1, let's say, and let's use, or let's reference the same one here. Okay. I found that it's quite useful or quite important to have the same translation for both ends. Otherwise, it can get quite noisy and quite weird. Like, this is definitely not what I would want. But yeah, so this is looking fine. Definitely we can again add a function top here and affect RGB with an input exponent, so we can hone in better on what we want to affect with our turbulence. That's cool. Let's make this noise move also. That's always good. Extended seconds. There we go. Next up, I would like to affect the size of these line material points. based on the color of the particles. So to do that, let's copy and paste these effectors. We need to again, let's rename this. Need to again rename this to eTurb. Yeah. And this to eSize. I'm gonna select this up here. And again, we need to reorder these into two separate color channels. That's gonna be our red, and input 2 is gonna be our green. And in the particles GPU settings, for the size type, I'm gonna set this to effector G. Oop. Yeah, that's gonna be an issue because our size lookup is, if we look inside, it's some diabolical value of 10 between 50 or something like that. So I'm just gonna put down a pattern chop here and set this to ramp, and set this as our size lookup. Now that's much more sensible, and it's doing already almost what I want. We can change the exponent value here as we want. They are getting a little bit too big though, for my liking. So we can definitely decrease the size here, range it to a bit lower. And that's looking nice. So at this point, it is good to add some feedback. So let's add some feedback from the palette. There we go. Connect it here. And that's looking like a nice particle system to me. We can still decrease the size a little bit, probably. Also change our exponent. However, we are still not fully done, because if I change this from a monochrome to a colored image, currently we are doing the lookup based on, for the turbulence, for example, only based on the red channel, and we don't want that. Essentially, a quick solution to this is changing this image to monochrome, and then you can decide what to use as a lookup. You can use the RGB average instead of luminance, or you can use just the blue or whatever. It's up to you, but it's looking quite nice. We can play around with the noise, have different looks. We can add, obviously, we can add different kind of feedbacks after this. We have a lot of options from here on out. Obviously, we can change what our input source is. So I could replace this with this image of a retina, and that will also still work nicely. And we can play around, make it look how we want. I'm just literally just going to play around with some of the parameters here. Okay, I think that's the principle of what we wanted to achieve here. This is quite a long and involved tutorial, I realize or recognize. But the thing is, this now works, and I think we gained a lot of good new knowledge about particles GPU and particle systems, and a little bit of GLSL here and there. As I said in the beginning, this project file is going to be available on my Patreon, and there's going to be a separate video up soon about the component that I created, which makes this all much more easy and much more simple to set up and use, with a lot of extra features that I'm going to talk about on Patreon, such as mapping the fade of particles to the size, and obviously a quick and easy mapping for the turbulence lookups, life lookup, wind lookup, there's a lot of cool stuff to see here and use, and there's really a lot you can do with this little component. So be sure to check it out on my Patreon. There's a ton of stuff there. Like really, there's a lot going back to the past. So yeah, I hope to see you around, and I hope you found this tutorial useful. And thanks for the support and everything. And yeah, if you have any questions, just feel free to ask me either here in the comments or better yet on Discord or Instagram. And see you around.